On February 6, 1970, Intel CEO Robert Noyce and Busicom president Yoshio Kojima signed a contract that effectively locked away the future of computing. For a non-recurring engineering charge of just $60,000, Intel granted Busicom the absolute exclusive rights to a custom chipset they were developing. At the time, Intel was primarily a semiconductor memory manufacturer, and Busicom was a Japanese company trying to build a better desktop calculator. Neither side fully realized what they had just formalized. That $60,000 agreement gave a calculator company total ownership over what was quietly evolving into the world's first single-chip microprocessor. If that contract had remained completely intact, the silicon revolution as we know it might have been trapped inside the plastic shell of an adding machine. To understand how Intel signed away its most important breakthrough, we have to rewind to April 1968. In Japan, Masatoshi Shima and Tadashi Tanba, engineers at Nippon Calculating Machine Corporation, better known as Busicom, began designing the logic for a new line of desktop calculators. Their goal was to use large-scale integration, or LSI, to pack more capability into less space. By June of 1969, Busicom representatives traveled to California to present their complex logic design to Intel, asking the young memory company to handle the custom manufacturing. Historical accounts actually clash on the exact nature of this initial pitch. Popular tech press and Intel's modern histories often state that Busicom requested a highly complex 12-chip set. However, Masatoshi Shima's own historical accounts indicate that their initial design was actually 7 LSI chips, which later expanded to 8 or 9. Regardless of the exact starting number, the design Busicom brought to California was hardwired and application-specific. It was built to be a calculator, and only a calculator. Intel's applications research manager, Ted Hoff, reviewed Busicom's blueprints and saw a radically different path forward. Instead of fabricating a multi-chip system uniquely hardwired for calculator math, Hoff proposed replacing Busicom's design with a simplified 4-chip architecture. The crucial difference was that Hoff's concept was driven by software instructions stored in memory. The hardware would be completely generic. The intelligence would come from the code. Working alongside Intel engineer Stan Mazur, Hoff defined the architectural specifications for what they called the MCS4. However, standard historical summaries often oversimplify what happened next by crediting Ted Hoff broadly as the primary inventor of the microprocessor. The reality on the ground was more complex. As Masatoshi Shima later noted, Hoff's conceptual architecture lacked the practical specifics required to actually function, most notably the precise decimal calculation logic necessary for a calculator. Shima had to step in and engineer those missing foundational pieces himself, collaborating heavily to refine the final specification. Conceptualizing the 4-chip architecture was one thing, but translating that logic into a physical, functioning silicon layout was another entirely. For months, the physical reality of the chip languished. That changed in April 1970, when Federico Faggin joined Intel. Faggin took absolute direction of the silicon design for the chipset, which was now being called the 4004. The pressure was immense. Intel had signed the exclusivity contract back in February, promising delivery to Busicom. Faggin worked relentlessly to translate the complex logic gates into a physical mask layout that could actually be manufactured. By December 1970, the first production run of the 4004 central processing unit was finally ready. The silicon was etched, the chips were pressed, and they failed completely. The entire batch was non-functional due to a single omitted manufacturing layer known as a buried contact mask. Time and money were slipping away. The engineering team scrambled to correct the missing mask layer, pushing a second silicon run through the fabrication plant in January 1971. This time, the silicon was flawless. The second run yielded fully functional 4404 processors. By March 1971, Intel successfully delivered the working chips to Busicom in Japan. The Japanese engineers immediately set to work integrating the silicon, and just 1 month later, Busicom successfully constructed a working prototype of their 141PF desktop calculator. The software-driven architecture worked exactly as intended. Busicom finally had their cutting-edge machine.
But back in California, Intel was slowly realizing exactly what they had built. They hadn't just created a calculator chip. They had created a miniature general-purpose computer on a piece of silicon, and they legally could not sell it to anyone else. The February 1970 contract gave Busicom absolute exclusivity. Even internally, some Intel executives were hesitant about the technology. There were deep fears that selling a general-purpose processor would alienate Intel's existing computer client base, who might view the semiconductor company as a sudden competitor. However, Intel management was eventually persuaded to embrace the chip for one highly practical reason. The 4004 could not run on its own. It required accompanying read-only memory and random access memory to function. Selling the processor meant selling more of Intel's core product, which was memory chips. But none of that mattered as long as Busicom owned the rights. The turning point arrived not from a laboratory breakthrough, but from a sudden shift in global economics. By May 1971, a severe calculator price war was raging across the industry. Profit margins were collapsing, and Busicom found itself struggling under immense financial pressure. They desperately needed capital, and they needed to reduce their component costs. Seeing the opening, Intel CEO Robert Noyce approached Busicom with an offer. Intel would completely refund Busicom's $60,000 development fee. In exchange, Intel would take back the rights to market the 4004 to non-calculator applications. Busicom, needing immediate financial relief in the middle of a brutal market crash, accepted the refund. It has been suggested that had the calculator market not crashed in early 1971, Busicom would never have sought contract renegotiations. Without that price war forcing their hand, the public microprocessor revolution could easily have been delayed by years, while the foundational technology remained proprietary.
With the legal chains removed, Intel moved rapidly. On November 15, 1971, the company officially announced the commercial availability of the 4004 microprocessor. They didn't host a massive press conference. Instead, they placed a bold advertisement in the trade publication Electronic News, declaring a new era of integrated electronics. Busicom got the chips they needed to survive their immediate crisis, but Intel walked away with the technological foundation for the modern world. The $60,000 refund proved to be one of the most consequential investments Robert Noyce ever made. The buyback of the 4004 contract fundamentally altered the economics of computing forever. Before this moment, the industry was largely defined by application-specific hardware. If you wanted a machine to do a new job, you physically wired a new machine. The 4004 established the absolute dominance of soft programmable general-purpose silicon. Hardware became a blank canvas, and software became the paint. A Japanese calculator company's pursuit of a cheaper adding machine accidentally forced the creation of the microprocessor. But it was Intel's willingness to buy back their own invention that actually gave that technology to the world.